All right. So it is about my journey through asset management and what I did after finishing my PhD as a postdoc, and a few of my ongoing projects. So a bit about myself. I'm a civil engineer by training, and after finishing my undergrad, I said, okay, that's it. Never ever going back to any academic situation. And I worked in industry for 5 years as a geotechnical engineer. And by the end of the 5 years, I realized that there are a lot of things that I didn't know. I said, okay, now probably I need to change my mind, and I went back to academia. I went to the University of Birmingham. I did in construction management. I tried geotechnical engineering, but it was an unsuccessful application. Then after finishing the construction management, I did a PhD, and it was on managing linear infrastructures and through a risk-based framework. It was more a case study was grid interconnections. It was completely new, the topic and everything. It was more on the application of risk-based approach. I'm a lecturer now after working for 7 years as a postdoc. But my entire, but from the MSc time, I've spent my time in Birmingham as a postdoc and then as a lecturer. And I'm now looking after our MSc program in road management and engineering. So my title as a lecturer is infrastructure asset management, but my focus is more around road and road management and road engineering. And there are some examples from that. So my journey after PhD started with a project called Assessing Down the Board, which I'll tell you about in a second. And after that, this project, Self-Repairing Cities project. And I have some statistics to explain the problem that we try to address. So pothole, which is this big, nasty holes in the middle of the road. It's a big issue in the UK. And it's a bit old of the figure, 21 seconds. Every 21 seconds, we have one pothole fixed. But I believe it's now much more than that. But after a pandemic, a bit of another sort of politics, there are more money into roads, but still a huge gap with what is really needed and what to address. So pothole is a big issue, an ongoing issue in the UK. And you can see other sort of problems and statistics related to that. At the moment, we have a reactive approach. We have potholes, and it's not in the UK, it's pretty much everywhere around the world. We have road defects, and then we go and solve them. All right, and normally it's too late when we try to solve them. And as part of this project, one aspect is that it relies on this process of repairing, relies on road workers, people going on the road, and it's quite a dangerous activity. There is a lot of incidents, unfortunately, fatal incidents, accidents around the world as part of this road work. And as part of our solution, Self-Repairing Cities project, we were looking into automation using robotic. So for detection as well as for repair. It was part of our visions for zero disruption from street works, road works by 2050. And you can see the list of partners. The University of Leeds was the PI, Birmingham, University of Southampton, and UCL in London. Different sort of expertise. A lot of people from computer science and robotic background, as well as engineers, and also the economic side of the thing, the human interactions. It was pretty much a large project, around £5 million for 4 years. And I was from the Birmingham team. This is again an illustration of what we tried to do. So on your left, the number one, if you like, this is our current approach, and it is the same. Yesterday, Sunday, I went around the city of Zurich, and it was around the old town. I could see the nasty trenches. They were not working, and it was just abundance of work for the weekend. But open cuts, a lot of small diggers, and it is a very tourist attraction sort of area. Obviously, the city wouldn't like to see these people walking in there, close to the public and the risk that they have to the public, etc. You can have congestion. You can disturb the traffic, and we know that staying in traffic would produce more CO2 emission and other sort of emissions. So this is our current approach, and our proposal was you can see at 2, 3, and 4, using robotic platforms to detect, and going for more proactive approach where you can detect defects as early as possible. So you don't need to then close the part of the road or the entire road and intervene as such. Then you can use robotic platforms. You can see a small arm in there to repair, but then not just focusing on roads, but other assets. You can see what we call green infrastructure. So you have parks and you have green corridors, and you have quite a lot in Zurich. To do that, the robotic platforms to inspect other assets for a city. And number 4 is just an example of what we develop. So you have a robotic, small robotic sort of platform on a vehicle, which a drone can carry around. And we use that for inspection of bridges where access to human beings is quite high. And small robots, they can go around the bridges. I don't have the video here. I don't want to go too much of details on the project that we did, but there was one robot with magnets that could go around a steel bridge and could then survey the bridge and give you a 3D model of the bridge and as an inspection type of approach. What I was involved in was more looking into this proactive approach. So you have a pothole, but what is the mechanism behind it? What happens that ends up in a pothole? And this was part of my job, and also working with other teams. So UCL in particular, they were material people, so they were into 3D printing visually. And then leads the robotic team, so identifying, detecting a crack, to go and measure the volume of the crack with laser scanners and from the images that they can take from the drone or robotic platform, and then to do this 3D printing autonomously. So that was a mini project as part of that bigger one, and you can see steps. Drones was selected to give that flexibility. So if you go for proactive approach in 2050, when you don't have human being, the idea was that you have these hubs in different zones of the city, let's say, areas of the city, and then it can deploy autonomously or semi sort of automation system. They can deploy these drones and they can quickly go during night. In the UK, you cannot work, for example, during night time because of the noise to the public. Well, that is the ideal time because traffic is minimum. So if you are doing anything on the road, you are not disturbing the traffic, or it's a minimized disturbance. But then, if we can do it with drones and we can deploy them and they can go and quickly fix a crack, then you can prevent pothole formation. So that was our sort of idea, and therefore using this drone approach. But we were able to use larger platforms, and then I can see people working on it. At the moment, there is a company working on that robotic arm. This is the drone that we developed. And you can see, I wouldn't go through the details, but I can see that it had a track, it could move once on the ground. And it was equipped with different cameras to detect, so to be used as a survey sort of tool to survey the whole area and identify cracks, etc. And then once on the ground to start following the crack, if you like, and treat it immediately. This is an image on the left-hand side. You can see before sealing the crack, on the right-hand side you can see after. That filled with bitumen. So part of the pre-stage was what temperature to use. Bitumen is, manufacturer wouldn't recommend going around 200 degrees Celsius. But then for the 3D printing, the higher temperature would make it more workable, so you would ensure that it would go through the cracks. So part of our research was finding the right balance, if you like. So having the right workability, if you like, of the bitumen, while not sacrificing that much on the durability of the material and the 3D printed finish. I can see a lot of crack sealing around the campus and in Zurich, but it's not the same in the UK. So road authorities, councils, they pretty much abandoned this crack sealing because of the hazard to the road users. So they wouldn't stay. Normally, the sealing, and there would be a hazard to the road users, smashing people, windows, etc. But yeah, it was part of our research. I mentioned finding the causes, if you like, of pothole as part of this proactive approach. And you can see in this image what we were trying to demonstrate. Is, assets, different assets, and from here is something that I still work on, because this is not the way that we manage our infrastructure. The way that we see our assets are as silos. So if I am a road authority, I only care about roads because it is my asset. But roads are built on ground. Within that ground and under the road structure or within the road structure, you've got buried utilities. Normally, the owner of these buried utilities is another organization. It's not a city council. It's water industry, for example, or water companies. There are some assets that there might be, but there might be other assets that they are not. They have different owners, and these owners, they are not necessarily talking to each other. So you can see here you have a leaking pipe, and these leaking pipes are not necessarily identified through the networks because the leakage can be small, and you can have softening of the ground. So then you have deformation in the ground. You can see the impact of that deformation in the road surface. So it's starting with some cracks. You might go and seal the cracks, but it wouldn't be the solution because the problem is a leaking pipe. Then you have a pothole. You have different distribution of your loading on the pipes because your road structure is not working properly. It's not distributing the load as you expect it to do. So you have more concentrated loading on your pipe, and then your pipe is already tired, it's already deteriorated, but you have further deterioration, and you have this loop. So if we go with a proactive approach, before intervening, before sealing the crack, you ask this question: what is the cause of that crack? If you have a pothole, what is causing a pothole? Can it be a leaking pipe? Do we know, do we have information about our pipe networks? Is there a pipe buried there? So the project that we did prior to that self-repairing project was something called assessing down the wall. And we were looking into identifying buried utilities and then trying to get information about them, so the health condition of these buried utilities. So that's why in this segment, so assessing down the wall and then self-repairing cities project. This is an example, a field trial that I did as part of assessing down the wall self-repairing cities projects. So there was a bit of an overlap between those two. This is on university campus. It was close to a demolishing site. It was old library. The university was demolishing. It was road section that you can see. So the photo in the middle, you can see a trench. And on the right-hand side of this trench, there was an old building, which is demolishing. There was a lot of heavy lorries going on this road section, with access to the site. And therefore, these trenches, you can see two of them, one near side to it, and the other one like a V shape far from us. Both of these trenches were under heavy loading. So we expected faster deterioration. That's why we selected these two trenches. Two trenches, pretty much similar. We followed both of them. We followed the standard in the UK guidelines. So standard, just the guidelines we followed, but the guidelines would give you a bit of flexibility. All right. So one was with highest standard, highest sort of end of material, compaction, etc. And the one closer to us, we tried to go with the way that the industry is operating at the moment. So the standard would suggest, just a suggestion, that they go and compact it in every, I think, 100 millimeters, or in every layers of material. But industry, they wouldn't have time for that. And then the UK system is a guarantee for only 2 years. And road is designed and built to stand normally 30 to 40 years. But if you dug a trench, if you do this what's called trenching operation, open cut, you reinstate it, and as a company, your liability will stay only for 2 years. Nothing can reach out to you and say, oh, there is a pothole because of your activity after that 2 years. But the way that they do it, because this is just 2 years, they are not bothered with compaction of each layer normally. They just compact it at the end of backfilling, and then one compaction after laying the asphalt. And we left a bit in the middle. So again, my sort of observation yesterday in Zurich, open trenches, and they were long distances. I would say they would leave it at least for a week or two. So you have water, you have rainfall. There was a bit of rainfall yesterday. Water going through your road structure. Your road structure is not designed to have water inside. That's why you use bitumen to seal the surface. But this is not the upper. So we tried to have this joint in the middle. We left it for the night, and that night there was snowfall in Birmingham. So then water as well as changes in temperature. And we had both trenches instrumented with different instruments. We had a pipe buried inside as well. And this is a year after installation. So the one on your right bottom, you can see red spots. That's the trench which I just described, the one which is with a joint in the middle, with minimum compaction and minimum compaction energy. I can recall the displacement of 70 millimeters in one point of that. Just to demonstrate that our trenching activities, our street water, as they are called, has an impact on our road networks. And by not considering this interaction, we are not managing our asset properly or in a sustainable way. So that's it with my previous slide. And this is what I'm doing at the moment. It's a list of my ongoing PhD studies, as well as the one finished, recently finished. So left-hand side, top, a digitalization of inventory. So the project that I described, self-repairing city automation robotic, how to do our inventory. The way we are doing it now, we have a lot of digitalization within that everywhere, in the UK as well as here and other countries. But this is just collecting data. It's not necessarily the way that we manage this data, we use this data. So a lot of work, my PhD student around that, managing data, how to use data. Part of it is, as you can see on the bottom of that box, condition prediction. So using this data to predict and prediction models, especially on road application, and using a probabilistic approach, and I'll show you an example later on. So application, road safety, improve road safety, improve the life of the asset. Part of that is to inform decision-making around selecting the best treatment strategies, what to use, when to intervene, how to intervene. If you have that in place, I would say that it is more viable. Someone from UK industry told me once, it was from the National Highways, so the agency who's in charge of UK motorways and the strategic roads. He said, if I have enough money, I know how to manage my assets. Thank you very much. I don't need your advice. I just don't have enough money. So that's what we are saying. Yes, we know that you don't have enough money. And our solutions are around that limited budget and hence the economy. Normally we have options and the industry, that's why they do trench. They know that they have impact. It's not that necessarily that they don't know. I believe they don't have the full picture because normally it's short-sighted. They are just looking into capital costs and they are not considering the OpEx, the operational expenditure and the whole life cost of the asset. So that's what we are trying to do. And the way that my team was working is around a risk-based approach. So what would be the risk if? And then that's how we develop different scenarios. So we have the Q&A at the end, and so I'll just carry on and then pause very soon. Now, so this is informing asset owners. I work closely with asset owners, and I try to have something for them, to inform them, and to tell them how we think we can improve the whole industry. And that will be the impact of the work. It's just a list of people and organizations that I'm involved in working with at the moment. And some of them different ends, so from academia, consultants, as well as funders of World Bank, for example. It's not only UK, it's not only developed countries. I have worked with developing countries, and I'll give you some examples in that end. This is one of my PhD students. Kuhn is towards the end of his PhD journey. This is what the framework that he developed. It is on digitalization of road network using, on the left you can see historical data, real-time data. He started with historical data, a database a lot of people have used and are using from the US because it's open to public. It's called LTTPP, long-term payment performance, something like that. It's good that it's available. We started from that database, and it was a numerical model combined with a data-driven, so machine learning approach to predict, for now, 2 different road defects, something called International Roughness Index, or IRI for short. It's unevenness of the road surface. In the UK, we don't use it. We have longitudinal profile, a different name, pretty much the same thing. It's only unevenness. And rotting is a permanent deformation on the wheel path. So we did that. And at the moment, Kuhn, with another PhD student, I'll show you in a minute, is using real-time data. So it's live data from an ongoing experiment, and there's some more challenges and research questions around. So one question I received from industry, that you're talking about live data. Do we need to collect live data for roads? Roads are deteriorating on an annual basis. What would be the point of collecting every second of data? What is the value of that data? So this is something that we're trying to address. On the probability side of the thing and risk and uncertainty, this is one of the graphs that part of PhD, Kuhn's PhD. So on the top one, you see just a prediction using data-driven models, so machine learning alone. The bottom one is using machine learning and a very basic numerical model of the road pavement. And what we try to do is randomness in selecting training and validation portion of the data. So the uncertainty just raising from that. And we try to limit the portion to the model. So it wouldn't be showing a range of, let's say, 1 to 8, and then asking machine or machine learning or algorithm to then predict a value of 11 to make sure that the machine would see all these ranges. But then just the uncertainty, so that different lines, and you can see quite an area in green, it's just showing the uncertainty raised from that selection of training portions. But you can see when we combine that machine learning with the numerical model, we reduce that range, so reduce the uncertainty. It would be just the start, and then ultimately it capture the uncertainty coming from data collection. So the US database is quite good, it's the best probably in the world, which is shared with public. But going through that data, you can see a lot of uncertainties, a lot of voids, gaps in the data, as well as a lot of noises. So the road you can see without any reason is improving itself. Would be just an error from the machine. And they collect sometimes sub-millimeter accuracy or claiming sub-millimeter of changes variation, while their devices wouldn't be that accurate. So again, a source of uncertainty. But at the moment, we are not capturing that. That was one example. Another example of that digitalization, it's Jonathan, and Jonathan ideas, he has access to a road section. So he has access to a road network, actually. It's a Nottinghamshire road network. And so it is what we call local roads. Local roads are rural roads and urban roads together. So not the strategic roads, not the motorways. So he selected one road section, to see it here. And then Jonathan is developing this idea of combining different sources of data. Some of them are accessible to the public, topology. You can see the drainage system to come after that. And this is something that Johnny developed, a GIS-based approach, as well as rainfall events. So these are available for everyone. Can we use these sources of data combined with road condition to then predict road condition in near future and in long-term future? And this is something that Johnny is working toward. And if we have that information, if we can predict, it can be, for example, as an application of this data set or this approach, can be predict hotspots, because water would stay on the road surface in this particular location, and that would be a hazard to road users. Another of my PhD students, and I think probably we're reaching the end of my presentation, a few more slides, but it's not very long. It's Reza. Reza is working with Kuhn at the moment on the live data that I said. So this is the Abacus model that you can see here. Reza PhD is looking into interaction between buried pipe and road surface. So the example I showed you before, if you have a leaking pipe buried on the road surface, can you see any particular defect in the surface? So when the other way, if you see certain pipe and we know there is a buried pipe, can we say there is a probability of having a leaking pipe there because of the type of defect that you can see in the surface? So started with the numerical model and to see what sort of stress, strain, and distribution of those you can see in the surface. And then he's validating his model using small-scale tests. So this is the test experiment Reza and Kuhn are working on at the moment. It's a box, a cubic meter box, and there is a pipe buried. So you can see the control section in the middle. A pipe buried under a road structure. We use cold asphalt to just simplify the process. Hot asphalt is fine, but it will be a bit harder to build inside laboratory. And you can see the pipe on the right-hand side, fiber optic around the pipe, some strain gauges attached to the surface, and some other equipment, and you can see the list on the left-hand side to ensure that Reza would get enough information to validate the numerical model. And this is just a small short video from the inside that can play, just showing the cyclic loading on the right-hand side. It's an actuator. On the right, I will put a pad on the surface to minimize the punching. This is simulating the traffic, that's the cyclic loading, and a GoPro inside the pipe just to capture the deflection inside the pipe. I hope for image processing later on to see the deflection inside the pipe, how pipe we came under the story. 1 million cycles of loading so far. And so Reza has finished the control section, and now the next test is having a wet area around the pipe to simulate a leaking pipe, just to simulating a leaking pipe. This is after the test, so a side of the box can be removed, and we removed it, and you can see, so you can see the sort of permanent information on the surface. So if you have a reading pass, you will have that permanent information under wear, and then some sort of rotting, and you can see from the side of the box. The test is conducted in this facility, so I have 3 slides on that to just introduce the facility that we have. The workers visit facility is called National Berry Infrastructure. This facility is relatively new, funded by the government, and it has, so it is 25 meters by 10 meters by 5 meters. So it's a large pit, and it would give you, so you can see here that you can have different bays, you can have the large scale test. We are just using sorry, a strong flow to do the small test. The initial plan was to have at least one large size demonstration. What we will see, as you may know, if you are doing an experiment, a lot of things can go wrong in experiments. So its time is always a big challenge, the experimental work. And so Reza is reaching pretty much the end of his active time as a researcher. I even have time for writing up. I wouldn't be able to do experiment, but there are plans to extend the project behind his PhD. And this is inside the pits, and you can see a large, relatively large pipe buried. We do different tests. For example, you can see from here the central bay has a moving floor. So there are 52 actuators, and they can move independently. So you can simulate a moving floor, or we can simulate the tunneling impact, for example. And there are projects at the moment going around that. Couple of slides, and that's it. Another thing that I'm working on is using this data. And this is a project funded by UK National Highways, and we got Atkin Reales, a consultant, as a partner of the project. Tom is working on that research project, and the idea is we use different, we have access to these different sources of data. Can we use this data to predict road user behavior? National Highways is interested because they want to see if they can use that information to inform decision making. At the moment, they have this net zero ambitions. They want to reduce significantly to zero the road and road network impact on the environment, CO2 emission and other sort of impacts. If they have roads with minimum emission, as a road user, if I still have my V8 engine with fossil fuel going on that network, they cannot claim this net zero. So somehow they need to have an impact on the road user. They need to talk to the road users. And therefore they are interested to see what is the models for when we make a decision, which road section to use, if you like, how to go from A to B. It's not always using road network, but sometimes in the middle of our journey, we might end up even using public transport. We might end up on their assets or a strategic road, etc. On this side of the thing, if you are socioeconomic side of the thing, I recently finished a project for an organization called PR. PR is a road, it's a global organization. They were established in 1908. There are a lot of countries over 100 countries part of this PR, and they were interested in social equity and social accessibility. So whatever we discussed about road network, having a durable road network, what about us? What about the human being? What about our access and social accessibility through this network? Where are we as part of this equation? Where is this social equity? It was quite interesting. We did this project for them, and I'm not going through the details, but I was looking into what they called global north and global south, so developed countries and developing countries. It was quite interesting. This concept of social equity, social accessibility, it's quite different, this two spectrum. For part of the world, accessibility is just having access, having a road from a village to a hospital. That's what they are looking for. While the other part of the world, this accessibility, equity have different meanings. Now they are talking about value of time. And the access is there, it's minimum access, if you like, is there, but it is different aspects. Just to show that it can be quite used, accessibility, equity. So you can see here different dimensions. It was part of our project that what we consider under this equity and social accessibility. Some project that I mentioned with National Highways, it would be in line with this. So it wouldn't be just the engineering, if you like, element. Tom background is not engineering. He's more coming from economy and social sciences. So this is the angle that we are taking. My last slide, sorry, it was longer than I was thinking. I use this all to inform my teaching. These are a list of the modules that I'm directly or indirectly involved in. And I'm very proud that I bring in this research into my teaching. And part of it is research projects. And you see in my undergrads, they have a share in my research about what I do. That's it. Sorry, it was longer than I was thought. And any question, any observation, any comments?
Thank you very much.